All right, mic is on. Thanks, Scott, for inviting me to speak today. The impetus for this project was a need discovered by conservator Ellen Carley here at the Alaska State Museum for this type of information to be made available to cultural caretakers across Alaska. Ellen and Scott's outreach is part of a statewide campaign that began in 1976 to help make important information more widely available to Alaskans. In their years at the ASM, they have received numerous calls and emails from people across the state asking to help identify white substances that they find on a variety of materials. People might see something white and fuzzy and immediately worry that it's mold. Well, sometimes it is, and sometimes it could be something completely different. For instance, salt efflorescence and fatty bloom can both often be mistaken for mold. So today, I thought a good way to introduce this topic would be to present some of the most commonly misidentified white stuff by hosting the first ever ASM online game show, appropriately titled, What's That White Stuff? And I'm going to ask all of you to be the contestants. So here's how the game works. I'm going to put up a slide that shows a detail of white stuff from an object. Since we're on sort of a time limit, you'll have maybe 5 to 10 seconds to wager a guess. We'll put up some options for each slide and take a poll to see what everyone thinks it is. You'll be able to answer the poll by clicking on one of the options A through E at the bottom of the participant list. You'll see at the bottom there A, B, C, D, and E listed. If you click on that, it'll put your answer up next to your name. So if you're right enough times, you'll win, well, you'll win bragging rights as the first and probably only contestants of What's That White Stuff? So if everybody's ready, we'll get started. So here is object number 1. This is a detail image from the interior of a Chupik wooden dipper. It belongs to the Alaska State Museum and was collected sometime between 1910 and 1921. Let's see what you think it is by entering your guesses. Do you think it's A, pesticide residue, B, salt efflorescence, C, fatty bloom, D, mold, or E, glass disease? And the white stuff you can see is coating the interior of the bowl along the sides here. So once everybody's entered their guess, then we'll get some results and see what the consensus is. And I'll have to enter my answer last, otherwise I'll just give it away. Okay, so I'm going to go ahead. And the correct answer is actually C. So this is, let's see here, where did that go? This is fatty bloom. And it looks like, okay, a lot of people are thinking it was salt efflorescence, which is a really good guess, and they both look really similar. This fatty bloom has formed primarily on the interior of the wooden container, and you can see an overall image of the container here. On a detail image from a similar bowl in the collection, we can see the crystals of fatty bloom even better. You see that the structure is pretty fine and has a very crystalline appearance. It looks sugary or granular and sometimes even has a bit of a sparkle or translucency to it, not to make it sound too appealing. This can often be confused with salt efflorescence. One way to distinguish between the two would be to take a small sample of the white stuff and place it on the slide. Salts are generally soluble in water, so if you place a couple of drops of water onto your sample, it should not dissolve if you have fatty bloom. While the simple solubility test cannot tell you for sure that what you have is fatty bloom, it nonetheless can help keep that hypothesis in the running and rule out soluble salts. Blooms, such as we saw on the dipper, might form from oily residues left on the wood from use. These might have come from food or other substances a wooden object might have held, or they could have been acquired from skin oils left during handling. For example, this could possibly be what is causing the whitish discoloration you see on the handle here. Oils and waxes may have also been applied by owners to wood surfaces to prevent wood from cracking and to enhance its appearance, similar to the way leather dressings have been used on leather artifacts. While this is generally not considered an acceptable practice today, it was not unheard of a few decades ago. All right, so let's take a look at object number 2. This is also an ASM object. What you're looking at is a detail from a wood Yupik fox mask. It was acquired by Sheldon Jackson in the Yukon-Kuskokwim Delta region and dates to around 1893. The white stuff that we're looking at is kind of this whitish to off-white coating that's over the entire surface, and you can kind of see the darker wood showing from behind it. So let's poll everybody and say what you think the white stuff is. Is it A, mold, B, pigment or paint, C, pesticide residue, D, fatty bloom, or E, delamination? And for those of you who have just joined us, you can see that at the bottom there are 5 choices that you can click on, A, B, C, D, or E, to register your best guess for what you think the white stuff is. And then once everybody's entered their guess, a little poll will pop up to see the percentages of what everybody thinks it is. All right, well, I'm going to go ahead and put in my guess, which is cheating because I already know what it is. And the correct answer is B, pigment or paint. So it looks like everybody kind of recognized what that was. This is a wooden mask that has a white paint or pigment applied to its surface. Sometimes if pigment was rubbed onto a surface or paint applied without much binder, then it may have more easily worn off over the years of use, leaving only trace amounts on an object. If it is not known that such paint is supposed to be there, then the traces may easily be misunderstood as some type of non-original accretion. Similarly, it is known that some Native American groups would rub white clays onto leather articles to brighten them, which leaves a white granular or powdery appearance on those artifacts. If these pigments or clays were to be misidentified as grime, dust, or some other accretion and then removed, then that history of the object would be lost forever. This is one of the primary goals for this project, to educate on all the different types of white stuff that could be found on an object so that misinterpretation doesn't lead to the loss of an object or its history of use. All right, here's item number 3. This is from a leather object that is also in the collection at the Sheldon Jackson Museum and was acquired sometime before 1933. It's known that it had been in the owner's family for generations, indicating the piece itself could date as early as 1850 or possibly earlier. Today it has white stuff over almost its entire surface. And it's pretty easy to see there where the white stuff is. What do you think it is? Is it A, salt efflorescence, B, fatty bloom, C, pesticide residue, D, mold, or E, delamination? So enter your best guess right now. All right, looks like almost everybody's entered their guesses. So this one was a bit trickier. Yep. And this is actually an example, again, of fatty bloom. It's fatty bloom on leather, and it provides a nice comparison to the fatty bloom we saw on the Chupik wooden dipper. This bloom was found on a Chilkat Tlingit armor that is believed to be made either from elk, moose, sea lion, or walrus hide. Records indicate that the object had leather dressing, which is a mixture of oils, applied to it many years ago by the National Park Service, before the collection belonged to the ASM. The fatty acids from these oils can break down and leach out over time, causing the white fatty bloom you see here. Tanned skins also naturally contain oils that can break down and crystallize on the surface. On leather products, any history of an application of leather dressing would be a good indicator that a white crystalline product on the surface is fatty bloom. These treatments were common in museums from the 1950s through the 1970s. You can also perform a solubility test like I discussed with the wooden artifact. Any lipid-based material, such as oils and waxes, will not dissolve in water. All right, so next up, number 4. So this is part of a necklace, which was also collected by Sheldon Jackson prior to 1933. So let's see what you guys think that white stuff is. Is it A, fatty bloom, B, mold, C, insect webbing, D, glass disease, or E, salt efflorescence? All right. Well, let's look at what the correct answer on this one is. And it looks like everybody, there's a good percentage of people, so 33% guessed the correct answer, D, glass disease. So let's look at the overall picture of this one. I thought the bright colors of the beads might give this one away. It's a great example of glass disease. So at a basic chemical level, glass is composed primarily of silica, calcium oxide, and sodium carbonate, which acts as a stabilizer and reduces the melting point of the glass. If there's an improper ratio of ingredients in the glass mixture during the production, particularly if there's an excess of the alkaline component, sodium carbonate, then the surface of the glass may begin to react with moisture in the air and start to break down. This can form a white haze or even a thicker white crust on a glass surface, like in the examples you see here. And then here again in the next picture, we can see this kind of thick white crust that's developing on that blue bead. And I don't know if you can make it out on these slides or not, but the red beads are starting to form a haziness, especially towards the center. Glass disease is not really a disease in the sense that it's contagious or can be spread to other glass objects, but rather the problem is considered an inherent vice due to the chemical makeup of the glass. Because of this, there is no way to prevent it from happening. However, controlling environmental conditions and keeping humidity levels low can do a lot to slow down the progression of the deterioration. So glass disease is probably one of the most common causes of formation of white crusty deposits on glass beads. This too can be tested if you have pH indicator strips like the ones you see here, or if you have the ability to purchase them online. They're relatively inexpensive, easy to use, and available from numerous retailers online. After removing a small sample of the white stuff from a glass surface and placing it on a glass slide, you can take a pH strip moistened with a bit of distilled water and press it to the sample. The example you see me testing here is a glass bead necklace from a study collection in Indiana, and I was able to test the surface of the beads directly using the same method. If the strip turns dark blue like you see on the right, this would indicate the presence of highly alkaline components and suggest the presence of bead disease. Okay, so I have one more question. This is the last slide. Well, last slide for the game show anyway. So this one's worth the most points. It's sort of a tough one, so I'll give you another clue. It's probably the most common white stuff you'll see in Alaska, but hopefully never on your collections. What's that white stuff? Is it A, mold, B, fatty bloom, C, salt efflorescence, D, precipitated dihydrogen monoxide, or E, paint or putty from exhibit? All right, looks like The majority of people are guessing A, mold. That's a good guess, but I'll admit this was a bit of a trick question. And the correct answer is precipitated dihydrogen monoxide, or AKA snow. So all kidding aside, while snow probably isn't going to be a major problem for your collections, I will use this opportunity to mention that fluctuations in temperature and humidity are the main culprits behind the formation of things like fatty spews, efflorescence, and mold. If you see these things forming on your collections, the most important thing to do is to determine what is causing them. The white stuff can serve as an alarm that something in the environment is not right, whether it's temperature, humidity, or off-gassing from a storage environment. There's something that likely needs to be changed. So thanks for playing, everyone, and for being such great sports. What I hope this little game did was to give everyone a bit of an idea of just how tricky identifying white stuff on artifacts can be, even for conservators. This is especially true if you're just looking at the white stuff itself and not the substrate or treatment history. In order to make this kind of identification easier for everyone, Ellen and I have been working on gathering information for various types of materials. We've been looking at things such as mechanisms of deterioration, commonly applied coatings, and damage from poor storage materials in order to provide a focused overview on what is most likely to be causing white stuff on an artifact. By making this information available to the public, we hope that people might be able to better identify what has formed or is forming on their objects. In this way, we hope to address not only the proper care for the object, but, as mentioned previously, the underlying factors in the environment that may be causing it. For example, the correct identification of mold not only provides direction in caring for an object, but raises awareness to protect oneself during handling. Most importantly, finding mold would indicate the presence of inappropriate relative humidity conditions that need to be addressed. Our information was gathered through a review of available literature, as well as an item-by-item survey of the collections at ASM in Juneau and the Sheldon Jackson Museum in Sitka. These collections belong to the state and represent the diversity of material culture that is likely to be found throughout Alaska. Our feeling was that whatever white stuff we found in these collections would be fairly representative of what people would find in other parts of the state. We are posting our findings through a weblog created through WordPress.com. You can access it at alaskawhitestuffid.wordpress.com. I'll post the address again at the end of the slideshow. You can also search for us by using the keywords Alaska White Stuff ID. In the introduction to our website, we propose a systematic approach to the problem of identification with the following 5 steps. Oh, and excellent. It looks like a link to the website has just been posted up on the chat column. So the 5 steps are: 1, identify the material affected. Look at it carefully. Is it stone, wood, metal? On a basic level, what is your artifact made out of? If it is a composite object, then what is the main material that the white stuff is affecting? Number 2, examine the context and history of the artifact. What was it used for? How was it maintained? Was it in a flood, or was it dug out of the ground? Has its environment been continuously stable, or was there any previous conservation treatment? Number 3, characterize the appearance of the white stuff. Is it powdery or sticky, flaky? Does it form a haze or a crust? Or does it appear in a pattern? Take a photo if you can, and then make notes to keep in the objects file. Number 4, consider the typical possibilities. For each kind of material, there are certain kinds of white stuff that we see more than others. For instance, corrosion is a fairly common cause of white stuff on metal. Like you see on the example on the left on the slide are, I believe they're lead hands or some kind of metal hands that are on a kayak. And then on the right, glass disease is frequently a culprit on older glass beads. A glossary is also, and 5, sorry, I jumped ahead of myself. 5, test the hypothesis. Make a guess at what you think it is. And if you can remove a little bit, test your theory. Guidelines for doing this will be made available on the website. A glossary is also posted on the site, as well as a thorough list of descriptive words to help you describe and categorize what you're seeing. We also suggest a master list of possibilities that may serve as a good starting point if you're feeling unsure as to what kind of material the object is made from. Be sure to write down your findings in the object record in case museum staff in the future have the same question. Postings on the website will be divided into categories based on material. So for instance, if you've analyzed your object and determined that you have a powdery crystalline white stuff on a leather belt, you can go directly to the leather section. There you would find any pertinent background information, a list of possible causes with descriptions for each one, and then references. There will also be galleries of images within each section to help the viewer determine what they are looking at. Each image in the section can be clicked on and enlarged to allow better visibility of the white stuff in question, so that comparisons can be made easier. Since there are so many kinds of materials and causes of white stuff out there, the scope of this project was simply to get as much information together as we could that would help people answer the question, what is that white stuff? Your feedback will certainly help. So as you look around the site and begin to use it, please leave us feedback in the comment sections. A number of individuals have also shared images with us of white stuff they found in their collections, and these are greatly appreciated as well. So thank you guys for giving me the opportunity to share with you the work we've been doing on this project. I found this research to be extremely interesting, and I'm grateful to have had the chance to be a part of it this summer. I'd like to give everyone listening in now a chance to ask questions, or if anyone has anything they'd like to add to this discussion, I welcome comments and suggestions. So thank you. Hi, Katie. I mic'd back in because I'm going to be a really slow typer. So yeah, PEG excretions, I mean, I think that's a good way of putting it. PEG is something that has been found a lot on not only spruce root basketry, but a couple of things. And it's something that Ellen's been talking a lot about, and she's done a lot of research with it. Yeah, like Scott said, she knows a lot about PEG treatments. I'm pretty unfamiliar with PEG, so I can't really comment on that any further. But I know if you have any more detailed questions about PEG, we could get in contact with Ellen, or she'd be happy to answer any questions about that. Thank you for the question, though. Hi, Dave. That's a really good question, and that is a hard one and something we've been looking at. One way is to kind of smear it on a slide, but the thing is if it's fresh mold, if it's living, it'll probably smear a little bit too. So your best guess is to probably look at it under a microscope if you have access to one. Again, like mold will look, if you can see it even under magnification, like the slightest bit of magnification, you might be able to see the fruiting bodies on mold, or they'll look like little dendritic, you know, like tree formations, whereas the fatty bloom should look a little bit more crystalline. But yeah, if you can get even some on a slide and put it under a microscope, that'd be the best way to tell the difference between those two. Yeah, like Scott's saying, mold does look like a plant, especially under a microscope. You would definitely be able to tell a difference. So I hope that answers your question a little bit. Hi, Monica. That's a good question, too. No, nobody has sent in any dust samples, and we haven't analyzed any during this research. We pretty much focused on the really thick accretions or thick white stuff that we were finding. But dust is definitely an option and would be something to consider. I would guess, I mean, this is just me taking a stab in the dark at this, but I would guess under a microscope, again, you'd be able to definitely differentiate between dust or more crystalline things such as cell efflorescence or fatty bloom. But that's a good point. Thank you. Yeah, Monica, that is interesting. I can't wait. You'll have to let us know what you find with the XRF. We've been having a lot of fun with it here and been analyzing a lot of different white stuff that we've been finding, and it's been really valuable in determining some things.
Dan.
Hi, Dan. That's a really good question. I would say, I mean, it's really important to look at what's causing the white stuff. So if you have something that's being caused by, oh, I don't know, temperature, humidity, like that's probably going to be the priority, because then you would need to change the environmental conditions. Mold is definitely a big priority, because if it's active, then it's feeding on your artifact. So that would be one to probably have conserved, to be treated, and to make sure that all of those mold spores have been removed properly. Anybody else have any ideas? Scott, do you have any ideas on that one? Okay, Scott's going to chime in here. I'm going to add one more thing. Scott was just mentioning a good point too, that fatty bloom in and of itself isn't really damaging to an object. So if it's just sitting there, it's not degrading the object, it's not producing any further damage. What's done is already done. And so it's not, I mean, it's unsightly and definitely it'd be an aesthetic reason to get rid of it. But as far as damaging to the artifact, it's not that detrimental.